Hello everyone, I would like to welcome you all in the video series called An Introduction to Perform 3D. Today the modal analysis in Perform 3D shall be done and compare the result obtained in Perform 3D with the uh, ETABS value or ETABS results, which is also another well-known applications of CSI. Also, we should be aware that while doing any analysis in softwares or in any fonts, the obtained results should be validated or the results should be calibrated with the established value, established result, or another applications or and calculations. So here in this video, the value obtained from the modal analysis in Perform 3D shall be compared with the value or the results obtained from ETABS for the same model and same loading parameter and every parameters same in both application. So let me turn to the model. In the previous video series, the load had been assigned to the beam element in all the beam element. Here we can see the variation of load, changed in load for each of the beam element. The load which has been applied to beam element is the area load, the gravity load that comes in the slab and is converted into the uniformly distributed load and applied in the beam element. So after the assignment of load pattern, let me move to the analysis phase. Here, there are so many options in analysis phase also. The first one is the setting of the load cases, run analysis. It's also run analysis parallel, and this is the tab for opening or for viewing the modal analysis results. This is for the energy balance. This is the limit state groups. This is for the deflected shape, and this is the time histories of the behavior of the structure and so on. So at first, let me go to set of load cases. Here, this is the modal analysis. So the gravity load case should be defined here. Let me name gravity load. And it's a linear option. So the load applied in one step. And here, the already defined load pattern to be added for the gravity load cases. It is clear in the model that we don't have any nodal loads and we have element load which we have defined in our previous video series. This is applied in the beam element, so we can put the scale factor of 1 because the dead load is already factored while doing calculations. So the factor here is 1 and the self weight of the structure has already been defined in load patterns, and so it should be assigned as a scale factor of 1. So let me save this. After this, let me move to run analysis series. So I have to define a new analysis series. Let me call modal analysis. So the description is modal analysis in Perform 3D and its comparison to or with ETABS. So here the basic parameter, we have to set some basic parameter in linear analysis also, but in linear analysis most of the parameter doesn't have any do not have any significant value, so the load sequence should be kept general or standard in this case, but while doing nonlinear analysis it should be kept general. So include be delta effect yes or no in this case, and then masses. Let me insert the number of mode shape to be calculated. Let me put 12. Then the masses, which is a mass source, seismic weight, we have assigned as a lumped mass for each story. The scale factor is 1. And let me click OK. Then after this, The analysis to be added, let me add gravity load because we have only one load cases. So let me run this structure. It's already done. Analysis were completed. So after this, let me go to model analysis results. Here we see the model analysis result tab. The modes, nodes, drift, and sections are present here in this tab. At first, let me check the model analysis result and go to mode. This displacement scaling is maximum displacement divided by maximum structure dimension is a scaling factor. By default, it's 0.1, and I think it's okay here. So let me go to mode number 1. Here, there are mode number 9s. So start from mode number 1. The model time period for the mode number 1 is 0.48 second. Let me float and animate. Okay, this is the animation as like ETABS for the mode number 1 in Perform 3D. And the mass participation factor for this mode is 0.702 or 70%, and along the S2 direction it's very nominal, it's around 1%. So the effective Bezier factor or mass participation in X direction, principal directions, the cumulative factor is 0.7137. Similarly, let me go to ETABS. This is the ETABS model which I have already defined and assigned everything required for the model analysis. Let me run this model. Here, after the analysis, let me check the time period of the structure. This reaction model information, model participating mass ratios, it comes with the time period. So let me check the time period of the structure. The first mode is along the x direction, and the model time period is 0.48 second, which is equal to the time period or model time period obtained in Perform 3D, 0.48 second. Okay, so here it's easy to see the model analysis results. The first mode in Perform 3D is 0.48 second, which is same as in ETABS, and there is slight difference in model mass participation. It's 0.70, here is 0.71. Then the summation of model mass participation factor in ETABS is 0.717, is 0.713. It means rounding two digit are the same. It means these values are compatible to each other, and the assumption we have made in Perform 3D seems accurate. So let me turn into mode 2. 0.4301, 0.43. Mass participation along S2 direction is 0.85, 0.85 here in ETABS also. Then along mode 3, 0.3658, while rounding up is 0.37, which is equal to the value obtained in ETABS, 0.37. Let me turn into mode 4, 0.1615 is also 0.16 while rounding off. So the model time period and model mass participation factors, they have matched with the ETABS value. So the model performed in Perform 3D seems accurate. So I'm going to check other parameters in Perform 3D. This is our file name is p3l. Let me open the backup files for Perform 3D. Here there are some values we have to understand regarding to model analysis. So here let me click this file m00, means the results are stored in the backup file after analysis has been completed. So here Here in Performance 3D, these these are the eigenvalues and time period as well as frequency here, frequency in ETABS and Performance 3D. And if we go here, the eigenvalues found in mode 1 is 1.7126 into 10 to the power 2. Here in ETABS also the eigenvalue is same. For mode 2, 2.13, 2.10 in ETABS. Similarly for mode 3, 2.95, there is 2.86. Similarly for mode number 9 in ETABS, the value is 4.51, and in performance 3D is 4.032, and time period of the structure in respective modes are also mentioned here in the backup files. So here these are the cumulative mass participation factor for H1 and H2 directions, and it is found that during the mode number 1 there is 100% mass participation in performance 3D as well. We can see that value in ETABS also. Yeah, in mode number 9 there is 100% mass participation. These values are also okay with ETABS, or perfectly match with ETABS. So after this, let me go to another text file in Performance 3D. So here there is a echo file in Performance 3D which is saved after the analysis. In this text file, all the input parameter we have assigned in Performance 3D. For example, these are the coordinates. At first we have assigned as a node. These coordinates are noted here. Similarly, all the input parameters which we have defined in Performance 3D from assigning the node elements up to the load are indicated here or mentioned here as output data. Here, these are the beam compound which we have made during the component definition. Column compounds also have been done. So this echo file is for the information of all input data, what we have defined or input in the defining phase of Performance 3D. So after that, let me go to echo 001 file. Here we can see the output results. For example, this one is the self weight of the structure. So the self weight of the structure have been reflected here. In the tabs, we call it as a dead load. So let me check the self weight of the structure and of in Performance 3D and compare with the tabs value. Here it's 1.092 into 10 to the power 6 total self weight of the structure in Performance 3D. So let me check this value in the tabs. Analysis, display, show tables. Let me go to this reaction here. Let me export this table somewhere in Excel. Then I need this one. So the dead load of the structure here, it is the dead load of the structure, it is 1.06, but in Performance 3D we got 1.092. So here the two values are more or less similar. Let me check another load pattern, which is the element load, dead load plus 0.25 live load, which means area load, or the load which has been assigned in slab in ETABS. So here in Performance 3D, the total load is 3 into 10 to the power minus 10 to the power 6 Newton. Here, if we add all the loads, it's 2.99 into 10 to the power 6, which means it's almost 3. So the load that has been assigned in both SAP and ETABS are also same. And at last, this is the energy balance in Performance 3D. Similarly, the model analysis results in ETABS and Performance 3D has been compared and illustrated here, because while doing any analysis either in softwares or by the hand calculation, The obtained analysis value or the obtained results have to be calibrated with the known value or the value which we are more confident. So we have done these things in Perform 3D and compare everything in model and related to model analysis into ETABS. So this is the complete video for model analysis in Perform 3D. And in next videos, we'll continue for nonlinear modeling in Perform 3D. So keep watching my videos, comment, and keep subscribing my channel. Thank you.